A very good morning to you, sir.
Good morning to you too. Good to see all you guys.
And a very good evening to everybody present here. We're really honored to have you here with us today. We've been really eager and excited ever since we got to know about this interview, sir. And if I'm not mistaken, it's your birthday today, right?
That's right.
A very happy birthday from our side, sir.
Very happy birthday, sir.
Thank you.
We thank you for taking out some of your precious time from your schedule to be with us today.
No, it's my pleasure.
Thank you, sir.
Well, sir, consider this as a part of your birthday celebrations. Hopefully, you will have as much fun as we plan to. Now, for those of you who aren't aware, Professor Vijaya Kumar Murty is a professor at University of Toronto and the director of Fields Institute. His research interest includes algebraic number theory, information security, and arithmetic algebraic geometry. Sir has also been co-awarded the Ferran Sunir Balaguer Prize along with his brother, Professor M. Ramamurthy, for their book Non-Vanishing of L Functions and Their Applications. So, let's begin the interview by diving into your motivation to pursue the field of mathematics. What do you think was your driving inspiration to get into this field, sir?
I think it's just a very beautiful subject.
Yeah.
It is a very powerful subject also. It's a way of thinking, and it allows you, if you understand it correctly, to solve many problems at the same time. Problems that others may see as different cases, but the power of mathematics allows you to abstract and solve them all at once. So I think it's the power of abstraction is one thing that's very attractive. Second thing is it is intrinsically beautiful. There's an aesthetic experience when you do mathematics, and frankly, because since I got interested in mathematics when I was very young, it's simply something one is able to do, and so you tend to like what you're able to do.
Also, did your brother, who was also your co-author in many of your papers, Professor M. Ramamurthy, play a crucial role in your decision to pursue the subject?
Absolutely, absolutely. I think I was extremely fortunate to have someone as close as a brother to discover mathematics with. So our journey started together quite a long time ago, and that I think certainly did play a very significant role.
It's really interesting how you got into mathematics. So, speaking of academia, does one frequently come across a complex problem or a topic? If so, would you like to walk us through the process of how you deal with it? And what advice will you give to college students should they face a similar situation?
Tough problem, you mean in the sense of a scientifically difficult problem or a human problem?
Scientifically.
Yeah, because there are all kinds that we face, and sometimes they're not so disentangled. Scientifically, you see, yes, of course, every problem is hard until we start to see how to do it. I think there's a saying in Sanskrit that it looks like it's Brahma Vidya at first, but once you figure it out, it looks like Bala Vidya. Once you figure it out, it looks easy to you, and you say, obvious. Why isn't this obvious to everybody? And why wasn't it obvious to me at the beginning? But it's always like that. So you have to remember that, so that when you see something that looks difficult, you remember you faced many situations in the past where you had a problem where you didn't know what to do, but you solved it. And so you arm yourself with that faith that I think I can do this, to look at the problem that is in front of you. This business of faith is, by the way, something I want to keep coming back to. It's really, really important in science, mathematics in particular, but science in general. It's really, really important. You have to believe in yourself that you're going to be able to solve this problem. If you start and I guarantee this is the reason why students who have difficulty, whether it's math or some other subject, the cause of the difficulty starts with them believing they're not able to solve the problem. Once you remove that and you say, I don't know how I'm going to do it, but I think I can do it, You start with that kind of attitude, sooner or later, you'll figure it out. Either yourself or you'll figure out who to ask for help. That's another skill. Who should you ask for help? So those things will come, but it has to start with faith in yourself that I can solve this problem.
That was very illuminating. Coming to your areas of expertise, which include number theory, algebraic geometry, and cryptography, will it be possible for you to give a description of some of your works in a way that an undergraduate student with basic knowledge of groups and rings can follow?
Sure. I mean, number theory, it's hard to define it, but a lot of the problems that are studied in number theory at least begin with issues concerning ordinary numbers like 1, 2, 3, integers, whole numbers, 1, 2, 3. And just as when you study science, you're looking for the atoms upon which all of matter is built up out of. So here in mathematics, the numbers at first instance are built up through the arithmetic operations of multiplication and division and addition and subtraction. So from that point of view, if you look at the atoms, you're led to prime numbers. That is, numbers that cannot be divided up or factored further. Like 3 is a prime number, 4 is not. 4 is 2 times 2. 6 is not a prime number, it's 2 times 3. So once you've discovered the so-called atoms, at least from the multiplicative point of view, now you want to understand how these are put together. And then it seems it starts to become very difficult at first. Even now, I think there are subtleties of prime numbers that we don't understand. So a lot of number theory is about understanding that relationship. Now, numbers you can do, you can not only multiply them, you can also add them. And when you combine these operations, then you get yet another level of difficulty. For example, one of the famous open problems, it's still not solved, is if I take a prime number, well, a prime number is certainly odd, except for the prime 2. Every prime number after that is odd, 3, 5, 7, 11, and so on. Then I can ask, if I give you a prime number, where is the next one? So 3, the next one is 5. After 5, the next one is 7. But then after 7, the next one isn't until 11. And then again, it's 13. And then after 13, it's 17. So the issue, what are the gaps between primes? How small can they get and how big can they get? That's a hard problem, which is still open. And lots of progress has been made in the recent past. But the problem itself is still open. So one of the things that I'm fascinated by, and others in number theory are fascinated by, are the distribution properties of prime numbers. Now, the next level of abstraction is to think of prime numbers or numbers as we just described them, to abstract it a little bit. That is, I want to think of geometric objects and see, do I have a concept of a prime number? Let's say I draw a curve. Is there a concept? So I have points on the curve, and somehow points on the curve I want to think of as if they're the analogs, the geometric analogs of numbers. Just as I thought of the real numbers, I want to think of points on the curve as some analog or geometric analog of numbers. And then I have a concept of integer points on the curve, just as I have integer numbers. I have 1, 2, 3 are integer numbers, but 3.5 is not an integer, it's a fractional number, or pi is a fractional number. So similarly on the curve, now I have integral points, and I don't exactly have a concept of a prime, but even the study of integral points tends to be a very difficult problem. So an example of this, which I'm sure all of you are familiar with, is what used to be called Fermat's last theorem. If I have 3 variables, x, y, and z, and I have x to the n plus y to the n equals z to the n, then I want to know integers x, y, z, and n that satisfy that. For example, 3 squared plus 4 squared is 5 squared. So x is 3, y is 4, z is 5, and n is 2. So a long time ago, a couple of centuries ago, an amateur mathematician, also a professional lawyer named Fermat, suggested that if I replace the squares with higher powers, there are no non-trivial solutions. There are always trivial solutions, but no non-trivial solutions. And that was only solved, about 20 or 25 years ago. It was open for several centuries. So that's an example of when you try to look at geometric analog of a problem that you understand on the ordinary integers, it becomes very difficult, and requires a large number of sophisticated tools to be able to address. And it was, as I said, this was only solved a few decades ago, even though the problem was formulated a couple of centuries ago. So the kind of problems I'm interested in is number theory in general, but also the connection to algebraic geometry. So the study of distribution of numbers, how they fit together in their additive and multiplicative structure, but also the geometric analogs of that. Now, this is a very, very beautiful subject. It's very beautiful for a couple of reasons. Firstly, you can explain it with very little technical background. You can go into a high school and explain what these problems are about, some of them anyway, to a student in a high school. Of course, the solutions will require more training to understand, at least those which can be solved. But firstly, the problems themselves can be explained to high school students. This is another point I want you to take note of, that understanding a problem is a really, really important step towards solving it. Again, I find one of the reasons some students stumble is they don't understand the question being asked. So being able to understand the problem, if you can develop that skill, that's already a very important skill. So the problems in number theory, I think, can be explained. It's beautiful because it can be explained to even a high school student, though maybe not the solutions. And the second thing is that nowadays we realize that those things that we thought were just beautiful and elegant and are aesthetic to work on and intellectually challenging and stimulating actually have application in the ordinary world, the physical world. I don't want to call it the real world. I call it the physical world, because the world of thought is just as real as the world of matter. And so when I say it has applications, people say this is the real world, as if what we do academically is the imaginary world. It's not. It's just as real. But it has application in the world of, in the physical world. A lot of what we call information security is built on ideas from number theory. And if you had said this a century ago, nobody would have understood. But this is the new opportunity that technology has made possible for us. See, it's another point to note is whenever the world moves forward in a different way of doing things, such as information technology, such as e-commerce, you as academics should all think about what's the new opportunity. And the new opportunity might not be the obvious one. So here, for example, okay, we have the internet, we have connectivity. Probably all of you are so young that you don't know of a time when there was no internet. So, but for me, I grew up at through the time where even email was new at one time. There was no email available to the public. It started as something created by the Defense Department, and then it became available to academics, and then it was a major idea of somebody to invent something called Hotmail. Email being available to everybody. And now, see, we can't think of life without email or texting or all the things that we use. But imagine when those things first came on, and then somebody thought, okay, maybe I can sell a product over this new medium. So e-commerce started. But the difficulty was this: if I sell you the product, how are you going to pay for it? I want to sell you a pizza, or I want to sell you a better still, okay, I want to sell you a dosa. How are you going to pay for it? So, well, if you were in a real store, you'd use your credit card, maybe, or your debit card. But if I'm on the internet and I'm ordering something, how am I going to give you I don't want to give you my credit card number or debit card number. I hope none of you do that, by the way. You should never give your account credentials over the internet just as it is. Why? Because the internet is, by construction, totally insecure. It is easy to eavesdrop. So you don't want your personal or a confidential information to be seen by people other than those who have a need to see it. The merchant who's trying to sell you the idli or those needs your card number to charge you for it, but nobody else needs it. So that's the question. The challenge now is, how do I give you my credit information or debit information without anybody else seeing it? And the only way I can communicate with you is on an insecure medium. So I can phrase this question in another way. Suppose I'm talking to you, let's say instead of on the internet, you're all in front of me in a hall, and I'm talking to you, and I want to say something that only, let's say, let me pick a name that I can see, Sayon Das can hear and understand. Everybody can hear it, but I want only Sayan to be able to understand it. Why? Because I'm going to say something secret. I need to tell him something secret. I cannot go over to his ear and whisper it. The only access I have is anything I say, everybody can hear it. Okay? And I need to tell Sayan a secret, and all of you will hear it, and you won't understand it, and only he will understand it. Well, if we had made a prior arrangement, if I knew this was going to happen, I would have, made an arrangement with Sayan separately and said, look, if I say one, I mean two. If I say today, I mean tomorrow. We'll agree on some code in some way. But I don't have that luxury. Because if I could go to the dosa vendor or the idli vendor and give that secret, I could have as well taken the idli too. Right? So here's the problem. How do I do this? How do I say in public, without a prior arrangement, how do I say something that only the designated person will understand and everybody else is hearing it, but they don't understand it? The answer is a little bit of mathematics, a little bit of number theory. So this is the protocol that enables e-commerce to work securely. So it's called a key exchange, and it's based on a little bit of number theory. So not only is this work interesting, beautiful, intrinsically for its own sake, but it also is the basis of an application in the material world. And it's a fundamental application. In other words, it's everywhere. It's everything, practically everything you do online, it will play a role. So it's really very, very important, very powerful kind of thing. So depending on and I'm interested in all of the spectrum, the pure problems just for their own sake and also for their applications.
Those were some great insights. Now, sir, talking about students taking up undergraduate degrees in sciences, there appears to be tendency to favor areas of applied mathematics over pure fields of the discipline. Given that the economies across the world are now industry-driven, and applied aspects of mathematics or any other subject for that matter are in demand. But even so, do you think that scope for undergraduate research for pure mathematics should be provided? How do you think the students can be encouraged towards it?
Well, it's a really good question, because this question is being asked in campuses around the world. And I have a very clear opinion on this. Absolutely, you have to get good at pure math and pure research. And remind me if I forget that at the end of this, I also want to tell you why you have to study humanities as well. Okay, so I'll come back to that in a minute. Let's talk about pure math. You see, when you say you're learning something, what is it you're learning? If you think you're learning a skill that will enable you to get a job, I'm telling you, skill-based jobs are relatively of low value. I mean, I'm exaggerating, and there are exceptions, of course. But what I'm trying to say is your greatest asset when you leave an academic institution is not the actual material that you learned. It's in your ability to think. Critical thinking is the most valuable asset you can bring to bear if you join any company or you're doing any kind of applications or any kind of research. The most critical asset that you can bring to bear on it is your ability to think critically, rationally, abstractly. We have at the Fields Institute, we started something called the Cybersecurity Training Program. So this program is for this. So we found two problems we were trying to solve. One is industry was telling us there's a shortage of cybersecurity professionals. There's a shortage of cybersecurity talent. You understand what cybersecurity is, right? It's security in the cyberspace when like the kind we were just discussing, when confidential information is being transmitted, how do you keep it confidential? So certainly financial institutions are very worried about that because people are shifting to online banking. So they were asking us, how do we get more people trained in cybersecurity? Okay. On the other hand, I saw another problem. People graduating with degrees in mathematics or related subjects who either didn't want or couldn't get academic positions and therefore were interested in industry positions. But the problem was their training was in pure math, or some pure subject. And so how do we bridge the gap? Well, the gap actually is pretty easy to bridge. We're giving them 8 weeks, just eight or 9 weeks of training in cybersecurity. And at the end of that, they're almost all of them are getting really good jobs in industry. And my point when I say this is that the reason we could do it in 8 or 9 weeks, I'm not trying to trivialize or underestimate the power of applied mathematics. I have great respect for applied mathematics. I also do work in applied mathematics. But I want to emphasize, even more than the subject you're studying, it's in your intellectual ability, your ability to think critically, rationally, to make things abstract. These are the tools that are the most powerful. So these people who were graduating, even in pure math, they already had those tools. So in a couple of months, I could easily give them the things they needed to know to succeed in cybersecurity career in industry. You see? So if you take your whole education as being equipping you for a job and I need to learn a skill, you're missing the most valuable thing that a college or a university education can give you. The skill, frankly, you can pick that up really fast. And it's not just my thinking, by the way. I remember some time ago, a VP from one of the major financial institutions came to my department. At that time, I was chair of the math department. And he said, could we have access to your PhD students, your graduating PhD students? I said, look, we are predominantly a pure math department. A lot of our students work in that area, and so I'm not sure they have what you're looking for. And he said, no. He told me his PhD is in pure math, and he's now vice president of this major financial institution. And he said, what the applied things, that the specific problems that I need your students to work on, I can teach them that in 6 months. But what I can't teach them is the ability to think abstractly, rationally, and critically. That's the most valuable skill. So therefore, that's why we're coming to you. So remember that what you're getting in a university or college education is not the specific subjects. It's your mind. It's a trained mind. It's a disciplined mind. The ability, mind that has the ability to think. The mind that has faith in itself. Remember, we said at the very beginning, you have to have faith that you can solve the problem. Those are the things that are most powerful, things that you can gain from a college or a university education. Now, I said I wanted to say something about humanities also. You have to remember always, and this is really important for you youngsters who are just starting out. I just said your valuable asset is your ability to think critically, rationally, and so on. But there's something even more valuable than that, and that's your humanity. Don't forget your humanity. You're human. This is so important, especially when information technology is becoming more and more powerful. And it's hard for us to figure out the difference sometimes between man and machine. And it's going to become even more so in the near future. We're going to be faced with really difficult ethical problems. I can do this, but should I do it? And these things, to get answers or insights or guidance to this, you're going to have to fall back on your humanity. So I think if you don't expose yourself to the humanities when you're in school, you're again going to find yourself shortchanged when you face the quote, again, I'm using this word, I don't like it, the real world, the material world. You're going to find this challenge. Therefore, if you, while you're in college, get really good at whatever subject you're studying. If it's technical subject or math subject, great, do that. But also remember your humanity. Study the great thinkers. I'm not saying you have to accept or believe anything they say, but study the great thinkers of the world. The world has produced many, many people with big head, big mind, and big heart also. Study them. Look at great literature, great poetry, great art. All of that has gone to make us the very kind of rich kind of spiritual entity that we are. And so it's that I would say it's not only the question of should I do pure or applied math, but I think you should do pure math, but you should also expose yourself to the humanities.
Thank you, sir. Going back to your PhD days, your PhD advisor, Dr. John Tate, was an Abel Prize winner. How would you describe the invaluable time you spent with him and the ways his personality influenced your own style?
Yeah, I think that's as I reflect more and more on those days, I realize he taught me a couple of very important things without ever saying a word about it. The thing that stands out most for me is he had a lot of faith in his students. So when you went to talk to him, he treated us not as the professor, you're the student, but so almost like equals. Now that has its advantages and disadvantages. It means he's not going to make any concession. You're a student, so you couldn't get away with this. No, he'd hold you up to the same high standard that he's holding up colleagues. And so you started to behave like that, started learning like that. And so that I think is a great lesson. And second thing is he gave a lot of freedom to students to explore their own ideas. As you know, in amongst thesis advisors, there are all sorts of different styles, and there are all sorts of different students, and you have to figure out which style works for which student. But his style, so sometimes it works that the advisor should give a specific problem for the student to work on. But to work with him, you had to be able to come up with your own problem. He was always he wouldn't say work on this, work on that. He'd say, you want to discuss math? I'm ready. Let's discuss math. And he'll hold, as I said, treat us like colleagues. He holds us up to the high standards, but he won't tell you do this and do that. You have to figure that out on your own. I remember once going into a meeting with him. I used to meet him weekly at the beginning of my doctoral studies. Later on, it became daily, but at the beginning, it was weekly. And then he said, okay, what have you been doing this past week? And I said, well, I've been reading this. I mentioned such and such a paper, but I don't have anything new to report. It's as a doctoral student, you're supposed to be discovering new things. So I said, I read this paper, but I don't have. He said, well, did you understand the paper? I said, yes. Well, so that's pretty important. You read an important paper and you understood it. That's why you say you didn't do anything. You did something. So he was like that. He gave a lot of freedom to students, and for me, I think it worked well, and it was. I now use the same technique on my students.
So it was great to hear that you had such an amazing guiding hand by your side. As Leonard Edelman aptly said, mathematics is less related to accounting than it is to philosophy. We learned that along with mathematics, you have been working on Indic philosophy. Would you like to enlighten us with some remarks about the connection of mathematics with philosophy in general and with Indic philosophy in particular?
Yeah, sure. I think firstly, again, mathematics enables you to think abstractly. So being comfortable with abstraction is a big gift, really. If you're able to come to that stage where you're comfortable with abstraction and thinking abstractly, it's a great gift. And philosophers, I think, have to think abstractly. Sometimes if you're coming at philosophy from a purely humanities background, that is without a scientific background, you may be you may not realize there are certain insights that science can really offer you. I remember when I was an undergraduate, I did take some philosophy courses, Western philosophy, and an argument was being made that if something is infinite, it's unique. Okay, if something is infinite, there can't be two infinities. And if you studied a little bit of math, you see that doesn't make any sense. That actually doesn't make sense. You can have two infinities. For example, here I can show you two infinities. Let's look at the positive numbers: 1, 2, 3, 4, 5, 6, so on. Let's add 0 to it. And then how about -1, -2, -3, -4? These are going off to infinity this way. These are going off to infinity this way, and they're different. They're disjoint, in fact. So that is a small, simple example of how your mathematical background can help you to pause a little bit when philosophers use certain words and say, what do you really mean by those words? Because unless you further qualify what you meant when you use the word infinity, to say that you can't have two infinities is false. So the mathematical or scientific background enables you to examine philosophical concepts more thoroughly. Okay, that's a general fact. So I would say that it is actually you're in a position, it's a kind of advantage if you approach philosophy having some mathematical background. Okay, that's one thing. But second thing is Indian philosophy is really quite a remarkable achievement of the world of humanity, I think, because as I studied and tried to explain this to students of Western philosophy, which was mostly what the class consisted of, I realized that there's some themes that are different in the Indian and the Western perspective. So that's what I began with. So question is the nature of the human being. So we ask, here's a question that concerns both philosophers, both East and West. Are we free? Is there such a thing as free will? And I claim the answer of both East and West is yes, we are free. The human being is free. Okay, but then the next question is, what is the human being? What is it that we're saying is free? And here, East and West gave different answers. So where we're agreed that we are free, but the Eastern perspective of what is free, what is the human being, is different from the Western perspective of what is the human being. From the Western philosophy, I am the mind. Who am I? I am the mind. And from the point of view of Indian philosophy, I'm consciousness. And consciousness can exist independently of mind. That's an Indian philosophical and spiritual perspective. We can argue the validity of those perspectives, that's different. But first, let's understand what is the perspective. The perspective in Indian thought is, I am consciousness, and consciousness can exist independently of mind. And both body and mind belong to nature, belong to the world of nature. Now, why is that? So this is the first difference in our point of view. But I'm starting here because when I explained this, then I asked the class, do you think that the study of philosophy is for intellectual stimulation? Is it like to be an armchair philosopher, to sit and think, oh, big ideas, what is the world, who am I? Is that the point of this, or does it have any practical value? Does it have any other value? And almost all of the class said it's mainly for intellectual stimulation. It's an intellectual exercise. And I said, I'm sorry, I disagree with you. See, your philosophical perspective actually shapes your world. And the point that I just made about what is the human being? Are you mind or are you consciousness? And are the two things different? Had tremendous implications for the way East and West developed. So in the Western world, you see, if you put these two questions together, I am free and I am the mind, if you put those two answers together, the implication of that is there is no science of the mind. Why? Because science is about discovering law, right? What do you do in science? You discover laws, right? And so if you're studying the physical world, law of matter, laws, you want to know the laws of matter. You want to know about gravitation. You want to know about electromagnetism. And those obey very strict laws. Nature is not free. It's constrained by laws. And those are the laws that we try to discover in science. So if I am the mind, and I am free, then the mind is not subject to law, cannot be subject to law. Therefore, there is no science of the mind. And that's why psychology in the West started so late. It's a consequence of this philosophical perspective that delayed the start of the field of psychology. In Indian thought, because mind belongs to Prakriti, nature, it is as subject to law as physical matter. Therefore, there is a science of the mind, and that is why we have the whole theory of yoga. The whole, especially Patanjali Yoga Sutras is it's psychology. It's about the mind. It's not about theology. It's about the mind. And the way they laid it out, the how you gain control of the mind, how you make mind do what you want it to do, you could. It's not a question of the actual things they discovered, but the idea that even such things are there to be discovered is a consequence of the philosophical position that I am not the mind. You see, so mind is subject to law. So I think I can go on and on about this. The point is, philosophy, especially Indian philosophy, has really, really lots and lots of profound insights, and you can better understand them, I think, if you had already learned to think abstractly, as mathematics teaches you.
It's always interesting to see humanistic perspectives in a scientific discussion. With reference to your article, Education and Development, we would like to know your views on the objective of education system and human development and evolution.
Those are big questions. How many hours do we have? So the point of education, I believe, I'm in total agreement with what Swami Vivekananda said on this. Education is the manifestation of the perfection already in a human being. So the Latin root of the word educate is to bring forth. It's to bring forth. In other words, something is already there, we bring it out. So, and then combine that with what Swami Vivekananda said, it is that there is tremendous talent, potential, even he called it perfection within you. And the whole educational process is to try to manifest that. And we do that through maybe this discipline or that discipline, but that goes back to what I was saying before. What you have is much more valuable than this discipline or that discipline. And I see there's a question coming here. I'll come to that in a second. It is something greater than a particular skill, your perfection, basically, that you're trying to manifest. So that is education. What was the other thing you asked about?
Human development and evolution.
Yeah. Human development. So therefore, that's exactly right. So everything I do, whether it's in school or outside of school, whether it's what I'm studying or whether I'm playing, the point should be to discover and manifest that perfection that is within us. So I call it, in fact, I have an essay on the science of human possibilities. So I think that is really what all of our education should be about. And if evolution, it is absolutely, we're still evolving beings, but I think right now our evolution is on the psychosocial level. So if to get to this point in our stage of evolution to the human, to the form where we're a human being, it was perhaps largely physical evolution. We are now at a point where what we're trying to figure out is how to evolve further in the psychosocial dimension. So, in other words, evolution of me not independently of you, but together. What are we as a community? And also to evolve myself psychologically. So, this is what I call psychosocial evolution. Now, there was something in the chat. Should I address that now or should I do it later?
You can check that now.
Okay, let's see what is the question here. If I understand it, determinism or possibilism? Which one you believe drives the world? I'm not sure I understand the words, but I'll take a guess. And if I'm wrong, then Mukund Madhav Mishra, who asked the question, can clarify and set me right. So, so determinism or possibilism, I think, you see, the point is this. Determinism in a highly complex environment is essentially not there. You see, if you have a very, very complex, you know what a complex system is? A complex system is if you have a bunch of particles, so particles are humans or whatever, agents, if you like, and they're interacting with each other. The rules of interaction can be very simple, but the number of agents is very large. Then even if you started out with simple and deterministic rules of interaction, you cannot answer or cannot very easily answer what actually is going to happen. I'll make this more concrete for you. Suppose you have a billiard table. Everyone familiar with billiards? It's like a table and then a lot of balls that you strike with a cue, and the ball will go and hit another ball, and that ball will hit another ball, and so on. Okay. So there are experts, and then the game of billiards is that you strike one ball and then you make another ball fall into a pocket. It's like caroms, basically. The Indian game of caroms. You have a carom board, and you have you use your finger to push one tablet to strike another tablet, and then you make it go into little pockets, right? That's how you get points. Okay. So from one point of view, that's totally deterministic. If I strike my carom is a certain force in a certain direction, you can tell where it's going to go, right? You can compute it. That's Newton's laws. So you can say the game is totally deterministic. It is in a way. But now, suppose instead of a small number of caroms, I have a big carom board and lots of caroms. And instead of 2 people playing, suppose I have 2 billion people playing, maybe a large number. What's going to happen? You can't say. Even though the rules of interaction were deterministic, the system becomes a complex system. And so the determinism on the whole becomes kind of stochasticity. You can only say with certain probabilities. You can't say for sure. So then what happens is there are all sorts of possibilities that have to be explored. This is, by the way, if we can come just briefly, very briefly, not for too long, back to the question about philosophy. When we talk about, in Indian philosophy, the theory of cause and effect, theory of karma, it is quite a complex, sophisticated, and subtle theory, and not something to be applied in a naive way. It's a very sophisticated, and the issue is this, that there are lots of causes and effects going on at the same time, and they're not independent. So things are affecting each other. So what will actually happen in life, we cannot easily predict it. It cannot be made into a naive prediction. Okay. Did I answer that question? Let me see. Mukund, did I answer the question properly?
Yeah, thanks, Professor Murthy. Even I am a naive learner of philosophy, so just the question came to me, and I think your answer was fabulous.
Okay, good, thanks.
So that was quite an enlightening view of looking at the relation of education and human development. Having had research experiences at the Institute of Advanced Study in Princeton, Concordia University, and TIFR, how would you compare the work culture and related aspects of these institutions?
So that's a really good question. And I think it's a very, very important question, especially as India is changing a lot. I think it's poised on a really, really important point in its development, where there's huge opportunity, huge potential. And so to take advantage of that opportunity and potential, we need to structure institutions that will really bring out the genius of the people and help them to grow as individuals, but also help them to channel that genius towards the growth of the country as a whole. So these three institutions that you just mentioned are very different. Let's start with Concordia University. It's a university. So universities, by and large, tend to emphasize it's a public university. So in Canada, I don't believe there are any private universities. They're all public. So public universities have certain obligations. They have to take a certain number of students. They have to teach certain courses and so on. So it was that kind of university. I felt that it did offer good opportunities for research, but mostly it was focused, I think, on teaching students certain skills that they needed to learn. The Tata Institute in Mumbai, it's a very nice place. It's a pretty elite place, and it's mostly a graduate school. They don't have undergraduates. They only teach master's and PhD level students. They take a very select small group of students and then give them sort of intense training. And then there are a lot of faculty who are also doing their own research. So that's a pretty good place for challenging each other. Often, if you want to do your best work, it's good to be around others who are trying to do their best work. We challenge each other, we push each other. So from that point of view, the Tata Institute is a huge success story. The only thing where I think the Tata Institute could do better, or maybe other institutions like it could do better, is, well, maybe it's not the Tata Institute doing better. I think maybe the country can do better, is there's got to be also opportunity for people at all gradations. In other words, if I make a very elite school where only a handful of students can get in, then I'm rejecting all the other people. Now, the other people, maybe for whatever reason they didn't pass whatever requirements were given at an elite place, but that doesn't make them. They still have talent. They still have knowledge. They have something to contribute. I don't want to lose them. I don't want them to get discouraged and go away into something else. So we need to create opportunities for them. So that's one thing I learned. The Tata Institute is an excellent kind of institution to have. You need several of those, but you also need to have other institutions that can pick up the people who didn't get into but who nevertheless are quite good and capable and have something to contribute, and give them an opportunity and chance as well. And the Institute for Advanced Study is yet another kind. By the way, you might know that Homi Bhabha, the famous nuclear physicist, who was, I believe, the founder, maybe the first director of TIFR, got his inspiration from Princeton, the Institute for Advanced Study. So the Institute for Advanced Study, by the way, it's interesting. It goes back to the question you asked right at the very beginning, was founded by a generous donation by a brother and sister. They were the Bambergers, and they donated money to have a place where great minds could just think. You didn't have to do anything applicable. They don't make a distinction between pure and applied. You just think, and you have freedom. So Princeton, the Institute, by the way, Princeton University is separate from the Institute for Advanced Study. The Institute for Advanced Study is set up like that. You arrive, your apartment is already ready, it's furnished, it's got everything there. You put your bags there, your office is ready, the office is open 24/7, the library is open 24/7, and you just get to work. And it's a really quiet environment, so you can really concentrate. When you get stuck on your math, there are woods surrounding the institute, you can go for a walk. And many great theorems have been proved during those walks in the woods. So it's yet another kind of place. So I think you need the entire spectrum. And what I'm trying to say is that everybody has something to contribute, and our educational institutions have to give that opportunity for everybody to contribute at different levels in different ways.
It must have surely been a pleasurable experience to have worked at such different places. So, what do you think of funding for higher education in India and how is it compared with that at other places?
So I don't know exactly what the funding for higher education is in India, but I can tell you in Canada and right now it's quite challenging. Partly because I think this idea that what is actually happening in an academic institution, it's not about taking courses and passing exams and getting a degree, but actually building your mind, building your own capacity, your capabilities, building the citizens that are going to build the country of the future. That point of view is difficult sometimes for policymakers to understand. It's even more difficult for people who have to whose existence depends on elections. It's difficult. We maybe have the luxury of being able to say those kind of things, but in practical terms, sometimes budgets are reduced when they don't see the benefit in a short time frame. India, as I said, I don't know the details, but I think you are in a better position. You're in a position to really, really make a difference. I'm seeing slowly the prosperity in India is increasing. And if the government were to invest heavily now into education, making education available to everybody and the entire scale, in other words, really elite institutions, but also other kinds of institutions where everybody has something to contribute, then you can get really remarkable results from that. Remember that if you want, by the way, when I speak to policymakers, this is what the example I give them. If you want to enjoy, I'm going to change it a little bit for the Indian situation. If you want to enjoy the mangoes, you should have planted the mango tree some time ago. You can't come to me today with just an empty plot of land and say, give me a mango. Mango is a fruit which grows on a mature tree. So if you want the people that are going to solve the problems, not only of today, but tomorrow, even the problems you don't know about, you've got to grow them today. And that's why you've got to invest in education at all levels and not constrain them by saying, look, we need you quickly to come out and build a bridge or so it has to be a little bit freer than that. There's got to be a bigger thinking that I'm planting a tree and that tree has to be nurtured. And in course of time, it's going to give me abundance of fruits and it's going to give shade and it's going to help the climate. All sorts of things are going to happen, but I need to let the tree grow first. So that is what I tell policymakers. It's that if they can afford to take the big picture, then they should invest in educational institutions and the entire spectrum of educational institutions so that everybody has an opportunity, and so that they have a time also to grow and mature and become the really great contributors to society that they have the potential to be.
That's a really great insight. So, as you've taught here in India, you might be familiar with the mathematics curriculum for the UG level in Indian universities and colleges. Do you feel that these are designed appropriately, or do you see a good scope of improvement in them?
To tell you the truth, I'm not that familiar with the undergraduate curriculum at Indian universities, and I know there's been a lot of discussion about it, and perhaps it's even being revised in the recently. There's always scope for improvement, but as I don't know the details, I can only comment quite generally. Um, I repeat that you don't need to compress a lot of material into the curriculum because it's not the material per se that's the whole value of an education. I really like the idea of less is more. Teach less, but teach it well, and help students to use that material to grow, to develop themselves. You see, a lot of things, our concept of what constitutes education and what constitutes knowledge is changing. You remember, you probably before your time, um, people used to have to learn multiplication tables. When you're young, by the age of 4 or 5, you know up to 20 times 20, you can tell the multiplication. Now, I'll leave aside for another time whether that's a good thing or a bad thing, but it was done. And nowadays, of course, if even your cell phone can give you multiply even more complicated numbers. And so you have to ask the question, do I need to teach them that or do I not need to teach them that? Again, I add a word of caution. I actually believe you learn. It is good to teach multiplication tables even now, and that what you're learning is something of value, something that your calculator can't do. But that's a different point. My point is that if you don't need to teach everything in school, because you're also able to get that. If it's just information, you're able to access that information separately now. And also remember another thing from the Upanishads, that student life begins, but it never ends. So just because you've graduated doesn't mean you stop learning. Always continue to learn and to teach. The Chandogya Upanishad says, Swajaya pravachanabhyam ma pramadaha. Swajaya is study for yourself, and pravachanam is to speak to others. Because when I say what I have understood to you, I understand it better. So the Upanishad tells you that, and what is the context in which that is said? That is said to a graduating student. A student who's about to leave the academy. The teacher says, please don't stop learning and teaching or speaking about what you're. So whatever the curriculum is in the university, that it is what it is. But even when you leave the university or the college, you don't stop learning. You have to continue your learning process. You have to continue speaking about what you've learned to others.
Thank you, sir. Next, I would like to ask, what's your perspective on the debate? Is mathematics discovered or invented?
So I know people have different opinions on it. My own opinion is that it's discovered.
So, coming to the end of this interview, we would like to ask a very important question actually.
Mm-hmm.
We all stride through some difficult times and hardships, which usually affect us in ways more than one. We're sure you must have had your own fair share of such low points. How did you manage through these situations, and what advice would you give to us budding researchers while facing these situations?
So this is a really very good question. I don't know how you whose insight was this. This is your original question. Very good. It's a really important question because you're absolutely right. Life is not about everything being rosy and going, as planned. It doesn't. Life is actually messy. Things happen that you didn't expect will happen, and you have to remember two things. Firstly, who you are. This is why teachings like what Swami Vivekananda said, education is the manifestation of perfection already in a human being. You have something great in you. And everything that happens in our life, you look at it from this point of view, that it's helping me to discover that which is within me. Even when I face a difficulty, and I come out of it at the other end, I look back at myself. When I was going in, I thought I couldn't do it. I thought this was the end. I thought things looked so bleak. And yet here I am. And I realize I'm stronger for it. How am I stronger? Well, firstly, I survived. But secondly, I can do exactly what I'm doing right now. Namely, those coming after are asking the same question, and I can tell them, don't worry, you're going to make it. You're going to make it because look at me, I made it, you're going to make it too. So face the difficulties because you are greater than any difficulty. You're greater than any difficulty, and more also equally important, you're greater than any achievement. Don't equate yourself with your achievements. I did this, I got the Olympic gold medal, so that's me. Well, a time will come when a beginner will be able to beat you. Because at a certain time in your youth and training, you got the Olympic gold medal. At a time will come when even a beginner will be able to beat you because you'll get older and weaker and slower. If I equate myself with my gold medal, then I will be destroyed. So you can overcome any adversity, and you're greater than any achievement. Don't equate yourself with your achievement. So it goes back to what I said. Remember, you're a human being. Humanity is the most important thing you have. Your humanity is the greatest thing you can contribute to society and to yourself. And what is the nature of that humanity? According to the Upanishads, it is pure consciousness and perfection. That's why Swami Vivekananda said education is the manifestation of the perfection already in man. You're divine. Divinity. I mean, just imagine from the human to the divine. So what you have, your potential, your greatness is immeasurable compared to anything that can get you down or anything that you can achieve. It's far greater than that.
Those words were indeed wise, sir. Thank you so much.
Thank
So
you.
it was an honor to take your interview.
Oh no, the honor was mine, and privilege was mine, and enjoyment was mine too. I always love talking to students.
We once again thank you in behalf of the Department of Mathematics by Hansraj College.
Okay. Thanks to everyone. Have a good
Thank
day.
you, Professor Murthy, for agreeing to this
Thanks.
interview. It was a
Thank
great,
you.
great experience for a student and for me as well.
No, thank you for the opportunity. As I said, we understand our ideas better when we express them. So it's good for me too. Thank you.
We would also like to thank our faculty members and especially Dr. Mukund Madhav Mishra for facilitating this interview.
Thank you so much.
Thank you so much, sir.
Good. Are we done?
Yes,
Yes,
sir.
sir.
Okay. Okay. Thanks. See you.